This is Lab 5 for Physics 1 at Georgia Tech. In this lab, I will analyze the motion of Newton's cradle and model it in VPython. First, I will observe a video and analyze the motion in Tracker. Then I will create a model in VPython that replicates the motion. I will discuss Newton's second law and the law of conservation of momentum. Newton's second law is also known as the momentum principle. It states that the change in an object's momentum over the change in time is equal to the net force on the object. Newton's cradle is a device in which a number of uniform spheres hang from strings of equal length. The size, length, and mass of the components are not important, only that the material is somewhat elastic. When one ball is lifted and dropped, it hits the others and causes a chain reaction. The ball on the other end mirrors its motion, and the balls in the middle remain almost stationary. This VPython model demonstrates an idealized version of the motion of the cradle. In real life, the spheres will rise a little less each time due to gravitational acceleration. This device is named after Newton because it models the conservation of momentum, which is derived from Newton's second law. The law of conservation of momentum states that during a collision in a closed system, the final total momentum is equal to the initial total momentum. This property is demonstrated in the motion of the cradle. The blue ball approaches the others with some momentum and collides with the green ball. After the collision, the blue ball no longer has any momentum. However, the green ball has a final momentum equal to the initial momentum of the blue ball. There is a chain reaction of collisions which ultimately causes the red ball to rise with the same momentum with which the blue ball initially collided, just as if it were swinging by itself. If the collision were not elastic, much of the energy of the collision would be absorbed, and final momentum might not be apparent. In conclusion, the law of conservation of momentum allows us to predict motion. Also, whether or not a material is elastic can be determined by observing its motion before and after a collision.